Hello students, the topic we look into today is AD converter, that is analog to digital converter. So analog to digital converter converts an analog signals into one digital signals. What we need, the purpose is, most of the signals are analog in nature. By converting the analog signals to digital signals, we may implement it in digital equipments we use in modern days. So, analog to digital converter. What is an analog? Analog is a continuously valued signal such as temperature or speed with infinite possible values in between. Whereas, what is a digital signal? A digital signal is a discretely valued signal such as integers and binaries encoded in binary. So these are the analog and the digital signal. What is analog signal? A analog signal is a directly measurable quantities in terms of some other quantity. Example, thermometer. Mercury height rises as temperature rises. Next one is the car speedometer. Needles move further right as you accelerate. Digital signals having only two states. For example, it has two states called 0 and 1. For example, in digital computers, we refer to the binary states 0 and 1. 1 can be an on and 0 can be an off. Next one is the example. So, light switch can either be on or off. Door to a room is either open or closed. These are some of the examples of the digital signals. ADC Basic Principle. The AD conversion, the basic principle of operation is to use the comparator principle is to determine whether or not to turn on a particular bit of a line number input. For example, it is typically for an ADC to use a digital to analog converter to determine one of the inputs to the comparator. So clearly we can say that a AD conversion is a quantizing process whereby an analog signal is converted into an equivalent binary word. Thus the AD converter is an exactly opposite function of that of a DA converter. It accepts an analog input voltage VA and produces an output binary word D1, D2, D3, etc. of functional value D, such that D is the summation of all the binary inputs, all the binary outputs. So as we said that we have analog input VA and output digital output. So the first digital output we call D1 is the least significant, most significant bit, and the last output DN is the least significant bit. So an ADC usually has two additional control lines, the start input to tell the ADC when to start the conversion and the end of conversion output to announce when the conversion is complete. So these are some of the points about ADC. ADC mainly uses a process called quantization. In quantization, we convert the samples of continuous value signals into a discrete value data. So what is a quantizing? The number of possible states that the converter can output is n is equal to 2n, where n is equal to number of bits in the AD converter. Analog quantization size is given by Q is equal to V max minus V minimum divided by n. So hence we may get a value of 1.25 old. So this is quantizing. Also, whatever I told, since we give analog input x of t, and by quantizing or AD conversion, we may have a digital output of b bits. Here, the quantizing is given by a step diagram. So here the values are quantized. Analog to digital conversion has several steps. First one is the quantizing, breaking down analog value into a set of finite states. Encoding, assigning a digital word or number to each state and matching it to the input signal. Step 1, quantizing. For example, you have 0 to 10 old signals. Separate them into a set of discrete states with 1.25 increment. This is what here is given as. We have 0 to 10 states and separated into a with finite discrement. The finite discrement is obtained by the quantizing value. Step 2, encoding. Hence we assign the digital value to each state for the comparator to read. So here we have assigned the value 0, 0, 0, 0, 1, 0, 1, 0. So these are the values assigned to each state. Sampling. It is a process of taking a sufficient number of discrete values at point on a waveform that will define the shape of the waveform. The more samples you take, the more accurately the output will be. It converts analog signals into a series of impulses and representing the amplitude of the signal. So we have three basic types. One is ADCs are classified broadly into two groups according to their conversion: direct ADCs and integrating type ADC. Here, this direct ADC has three types when compared to a given analog signal. So one is the flash type ADC, next one is the digital type or dual slope or counter type ADC, and the next one is the successive approximation type. So first one, so this is the sampling signal, and flash. First one is we look into is flash type ADC. So a flash type ADC consists of a series of comparators, each one comparing the input signal to a unique reference voltage. The comparator outputs connects to the input of a priority encoder circuit, which produces a binary output. So in general, a flash type ADC is also called as a parallel comparator ADC. So this is the simplest possible AD converter, and it is the fastest and most expensive type. So how this ADC works is that at each node of the resistive divider, a comparison voltage is available at the nodes and are equally divided between the reference voltage VR and the ground. The purpose of the circuit is to compare the analog input voltage VA with each of the node voltage, and hence the circuit has an high advantage of high speed as the conversion takes place simultaneously rather than sequentially. So this is the ADC converter. Whatever I told is that so this circuit consists of a resistor divider network, 8 op-amp comparator, and 8 line through 3 line encoder. So this is 8 line to 3 line encoder. The comparator and it has a truth table. So when VA is greater than the VD, then the logic output is 1, and when VA is less than the VD, then the logic output is 0. When VA is equal to the VD, then the output may be the previous value. Next, advantages of flash type comparator. simultaneous type AD converter is fastest. So this is the fastest and the construction is simpler and easier. Disadvantages, it is requires a more number of comparators, expensive and lower resolution. Next one is the dual slope ADC. Dual slope ADC. In dual slope AD converter, the integrator generates two different ramps, one with the unknown analog input voltage Vi as input and other one with the reference voltage minus Vr to the input. So dual slope conversion is an indirect method for AD conversion where an analog voltage and the reference voltage are converted into time periods by an integrator. So dual slope functions. The dual slope functions ADC function in this manner. So when an analog value is applied, the capacitor begins to charge. The counter continues to count until it reaches a predetermined value. Once this value is reached, then the counter stops and the counter is reset. So this is the dual slope ADC converter. So we give an input and the counter counts until the charged. This is controlled by the control logic. Next one is the successive approximation type. It is the most faster than the digital ramp ADC because it uses a determined voltage to converge on the value closer to the input voltage. So successive approximation technique uses a very efficient search code engine strategy to complete a n byte conversion. An 8-bit converter would require a 8-bit clock pulse to obtain a digital output. So the circuit uses a successive approximation register and to find the end of conversion required for each bit, and it uses the trial and error method. So this is the successive approximation type ADC. So the operation as with this arrival of the start command, the SAR sets the maximum significant bit, and with the arrival of the end of conversion, the comparator changes states and the comparator changes its states. So this is the successive approximation type ADC. Okay, so these are the comparisons between the three types of ADC. For a dual slope ADC, speed and cost is slow and medium. For a flash type, very fast and high. For a successive approximation, it may be a moderate of the two. So examples of AD conversions include microphones, strain gauges, thermocouple, voltmeters and digital multimeters. Thank you.